Hello everyone, welcome back. In this week's lesson, we're going to be talking about raw data. We're going to take a little bit of a shift from previous weeks, and we're going to go quite low level this week, really talking about this idea of just working with files and then using the raw bytes and bits that the files contain to make something happen. And we're going to look at that from two perspectives, both of them using a library called glitch.p5, not to be confused with Glitch, the platform we're using to write our code, but a library called Glitch that's all about working with files and then changing their contents to create glitches and errors into the files. So we'll do an example where we're going to glitch some JPEGs, some image files, and talk about things we can do with that. And then in the second example this week, we will use the same library to access individual bits of information contained into a file, so individual ones and zeros. And inspired by the work of Ryoji Ikeda, we're going to create a composition that's going to create an animation that's driven by the zeros and ones contained inside a file. So let's jump right into it. Okay, so as usual, we are going to start with a remix of our blank sketch. And let's give this a name right away. We're going to call it glitch. And at least for this, let's call it glitch image. Okay. And in this first example, we are going to talk about this idea of glitch, not in the sense of, the platform we're using, but this idea of opening up a file and just looking at its content, its raw content, and then making some changes to it to introduce some errors in the file. And those errors will get interpreted in interesting ways depending on the file type. This is an fun technique that a lot of people have been playing with. Sometimes it'll be referred to as data moshing, right? So are kind of taking a raw data and then just messing with it, basically, just to see what happens and what kinds of happy accidents can come out of this process. So what I mean by raw data, so for example, we're going to take a look at some files we're going to play with today. So let's say we have this image file. Okay, so I'm going to open it here. This is an image I got from Pexels, the site we used earlier. So it's free to use. It's a stock photo of this hitchhiking astronaut. Okay? Now, we see this as an image, but this is a JPEG file format, so it is a compressed image file, which means inside this file there's data contained in it, right? There's ones and zero or bytes of information, and when software reads the file, it knows how to interpret it because it's a JPEG. So if we wanted to see what's inside, we can open up the file using what's called a hex editor. Okay, so I'm using a hex editor here called HXD on Windows. There's other free ones on Mac. If you Google free hex editor, you will probably find something for your platform. And this is not necessary for today's example, but just to show you what we're going to be doing and talking about. So if I'm opening this JPEG here inside my hex editor, what I can see on the left here is so this is the actual contents of the file. And it's showing it to us in two different formats. One is as successive bytes. Okay, so these pairs of characters here represent bytes. Okay, so FF, right? This is a number in a format called hexadecimal or base 16, and what that means is it's basically the same as decimal, except instead of having 10 digits, right, 0 to 9, in hexadecimal we have 16 digits, right? We go 0 to 9, and then after 9 we have A, B, C, D, and F. So it so happens that a 2-digit hexadecimal number, such as this one, FF, in decimal, that means 255, or the biggest number we can store inside one single byte of information. So in this table over here, the values are represented as hex or hexadecimal numbers. So these are, each one of these pairs of characters is 1 byte in the file. And then on the right here, this is the bytes interpreted as text. Okay? So when you translate a byte into text using a table called ASCII, this is how you get characters depending on which which number you have. So for example, the number 48 is the letter uppercase H. And sometimes, so we can see that there's a little bit of text in here in the file, right? In the JPEG file, we can recognize some words, right? Profiles. Other elements are just, these are just, the bytes are just being interpreted as text, but as we scroll down, we'll see that as we get into kind of the meat of the image, right? This just becomes, this is just the compressed image data, and it just goes on for quite a while. Okay? So like a couple of things we can point out here already in this file. So for example, we know this is a JPEG because each file format starts with a specific code. Okay, so JPEGs always starts with FFD8. That's kind of the signature of a JPEG file. Other kinds of files will have a different code here, and this is how software can know when it opens a file, oh, I'm dealing with a JPEG here. And then it's going to know how to interpret the following bytes that it's going to find inside the file. And usually we have kind of two different sections to a file. We have something called a header, which is kind of the meta information, metadata about the file. And that's going to be different for every format. Something like JPEG, for example, doesn't necessarily have a fixed size for the header, but it contains a whole bunch of information, like the size of the image, information about the way the encoding has been done inside the image, and so forth. Different things called quantization tables. We'll come back to that in this example later on. So the header is kind of a metadata portion that usually you don't want to mess with unless you really know what you're doing, because then you will break the way the file can be interpreted by software. And then once the header is finished, which I don't know exactly where it happens inside the JPEG, but it looks like, once we get out of these areas with a bunch of dots here, this looks like probably the end of the header. We start to get into just data, right? So now this looks like garbage, but in fact, this is the image data that is represented as compressed information. Now, when a program opens up an image file, right, it knows to go through these bytes of data, and it follows a specific algorithm to decompress, to interpret this data, and then turn it back into image pixels. But all kinds of interesting things can happen once we start to just mess with this, and we can go and change some values and sort of break the file in some ways and just introduce some errors and introduce some changes that will be interpreted by the algorithm decompressing the file, and sometimes to surprising effect. That's why JPEGs work really well for this, because of the compression. File formats that don't have as much compression are a little bit easier to get cool changes when you're glitching the files. And those ideas we're talking about today, you can apply to all kinds of files. In the next example, we'll do a quick audio example. You could also, if you're more ambitious, try to modify, movie files and see what happens. Okay, so this was a long preamble just to kind of talk about, today's theme is we're going to open up files and really dive into their guts, the data that they contain, just the raw bytes and bits, and just go manipulate those directly to see what we could make happen. In the first example, we're going to manipulate the bits and transform the file. In the second one, we're going to use the bits as data and just read it to make something visual happen on the screen. So with a hex editor, you could use a hex editor, and one of the things a hex editor does is you can go and replace, you could go and start editing the file. I won't edit it here because I don't want to break my file. You can do some manual edits. There's lots of great tutorials online on different techniques you can use. You can open files inside software that are not designed to manipulate them, like opening image files inside something like Audacity, a audio editor, and then applying some effects to it just to really mess it up. But today we're going to explore opening files in P5.js, just to continue with our P5.js lessons. And we are going to use a library for that called glitch. So I'm going to bring up the tab here. So p5.glitch was written by Ted Davis, and this is a library that's been created to make it a little bit easier to open and manipulate files inside P5.js. So the first thing we are going to do is install the library, and there's a few ways we can do it. We could download the file, but we're going to just use the link here to install it. So I'm going to copy this, go into my index, and we're going to paste this to include p5.glitch.js into our sketch. And then now that we've done this, we now have the ability to create a glitch object. So here they're telling us p5.glitch is a class. So we're going to be able to create glitch objects, right? We can have multiple instances, and we're going to attach to it some image data or some other file data that we want to manipulate. Yep. And we're not going to go through the whole reference, but we will build an example that's going to kind of play with some of the possibilities that the glitch.p5 library affords us. All right. So now that we've imported the file, the other thing we're going to need is some assets. And I'm going to open my downloads here and just copy a few files. So just for this example, so I have this hitchhiker. I also have this black and white picture of New York City. So also from Pexels, great source of free images. And I'm going to leave that one for the next video, the MP3 file. So now we have two images. I'm going to copy this URL here. Let's define a variable at the top called image URL, so we can refer to it later on. Okay. All right, and and then let's load this image and attach it to a glitch object. So glitch is going to be our glitch object from the library. Right? So we're going to make it a global variable so we can access it everywhere. So this is going to be equal to a new glitch object. And then after we've done this, we are going to load an image. So let's load the image URL we just put into this variable. And we're going to define a callback function, right? That's going to run when the the image is loaded. Okay. And we're going to define that callback right into the load image as a kind of on-the-fly function, anonymous function. Okay. So this runs when the image is loaded and ready. Cool. Okay. So what we're going to do next is we're going to say glitch.loadImage, and the parameter is going to be our image that we loaded. It's coming to us as this IM variable here. So I'm going to say glitch.loadImage, and then in draw, just to see that this works, let's make a black background, and then we are going to say image glitch.image. And then just try it at 0, 0. Cool. Okay, so let's go over what we did just real quick. So we created a glitch object. Then we are loading an image here, and we're using the callback method to know that our image is ready to go and loaded. So this is the image URL we're loading, and this is the callback function. This function is going to run when the image is ready, and when it is, we attach it to our glitch object. So we're loading it again. It's called loadImage, that function, but really what it's doing is it's loading it internally into this glitch object. So now we can refer to it through glitch.image, and we can draw it as an image. Okay. Now, before we do some glitch examples, we are also going to resize our image. So we may notice this image is bigger than I have space here in my demo frame. So let's resize it. And we did this in last week's example. So we're going to resize the image, and we're going to resize it in such a way that we maintain the aspect ratio of the source image. So we're going to assume here that for simplicity that my images are all going to be landscape orientation. If they weren't landscape orientation, I would have to change this algorithm a little bit to check which dimension is the widest first. But for simplicity, I'm going to assume landscape. Okay? So we're going to resize the image to so that its width equals the width of our window. Okay? And now our job is to figure out the height of the image so that the ratio remains the same as we had with the original image. So we're going to say, let's figure out what that ratio was, right? So the ratio is going to be width divided by the image's initial width. original width, right? So this now becomes the ratio, right, that we've scaled our image by. So we're going to multiply that by the image's original height so that we can scale at the same ratio, right, as we're resizing for the width. Okay, so now it's fitting the image, right? And let's throw in also this bit here just to get rid of the scroll bars. Perfect, just because they are kind of annoying to look at. Okay, so now that we've resized the image, there's a few things we can do also right before we load the image into Glitch. One thing we can do is we can use Glitch as kind of a built-in pixelate effect. So by default, pixelation is a factor of 1. And if we go less than 1, it's going to kind of create like a pixelation effect with hard edges on the pixels. So it's not really like a resizing. You know, if I go lower than this, so it's creating nice hard edges on the pixels. So this is a cool little effect that you can play with. The other thing we can do is we can affect the quality. So when we load the JPEG information, we can affect the JPEG quality. So by default, the quality is 1, excuse me. And if we lower the quality, we can start to play already from the get-go when we load the image with, it's a bit hard to see here, with 0.5. Let's keep lowering that number. See, now we're getting artifacts from extra compression in the JPEG, and you can really like go pretty hardcore with this. So you can kind of intentionally reduce the quality of the image as a first step if you want to your data mangling process. Okay, so these are, and of course you can go any other kinds of values. So these are like things we can do globally before we load the image into our glitch object. Now, once we've done this, the whole purpose of the glitch library is to go, remember our hex file, is to go and be able to edit the content of the image file by doing some byte manipulation. Okay? And there's a few ways that the library will allow us to do this. One way is going to be to basically to go in and say, okay, take one of these bytes at random, right, and just replace it with a new byte at random. Okay? So let's see what that would look like. So we're going to say glitch dot random bytes, okay? And we are going to say 1. Okay, so this is going to take 1 byte and it's going to just randomize it. Now, every time we change the bytes inside the image, we also have to call glitch.buildImage. Okay, call anytime you've changed the bytes in the image. Okay, and that's going to update the actual image file so we can see the results. Let's hit refresh. So now we can see that over time, our image is going to get progressively worse because what we're doing is we are going inside and randomly taking one of those bytes, right, that we had over here, and then just changing it to something totally random. So it still will understand this as an image, but you know, very quickly things start to get nuts a little bit. And yeah. So this is one way that we can start manipulating images by changing their raw data. You'll notice also it's a little bit slow, right? So even though we're doing it every frame here, the frame rate drops quite a bit. So when you're rebuilding these images, Glitch is not the fastest library around. So for like real-time stuff, it still does it in real time, but it's a little bit slow whenever you process one image. Okay? So you may notice one thing interesting that's happening here is that there are no changes in this upper portion of the image, okay, just on the bottom here. And that is because, excuse me, of this idea of limiting which bytes the glitch library has access to. Now, Glitch doesn't, this library doesn't really make too many assumptions about what kind of files you're going to open with it. It has a few image-specific features, but other than that, you can kind of open any file, like you could open an executable, a movie, a sound file, and then just kind of start messing with the bytes. And remember, we had this concept of we have a header, which is a chunk of bytes at the beginning of the file, which tell you, oh, interesting. I'll come back to that in a sec. A chunk of bytes at the beginning of the file, which tell you this is called the metadata with the file. And normally you don't want to mess with the header too much unless you're going and doing some very surgical changes, because it will essentially corrupt the file and make it unreadable if you mess with the header too much. So to kind of deal with that, the library has a kind of a safe area that it allows you to make changes to. And the way that it defines which bytes can be affected by random bytes is using a function called limit bytes. Okay, so limit bytes takes two values. Both of them are from 0 to 1, 0 being the beginning of the file and 1 being the very last byte in the file. And by default, limit bytes is something like this. So it basically means the first 20% of the file is limited. Okay, so it's taking a very conservative approach, and it's kind of making the first top of the file off limit, so we don't accidentally change things in the header and just make the image unreadable. Which, by the way, will happen sometimes. If I open the console, it hasn't happened yet, but it will happen eventually. I'm going to leave that open for now temporarily, and we'll play with this and break the file so you'll see what happens. So for example, if I set a limit bytes of 0 to 1, like every byte is fair game, once in a while I'm going to get some errors, right? I'm going to have trouble building the image, and at some point it won't even render, right? So now very quickly this is broken. Okay, so so the limit bytes, so the 20% start time bit is a little bit conservative, because you can see that it really creates a whole top of the image that's not being affected, right, by the glitching. So we can lower that quite a bit. For example, if I increased it to 1.5, you'll see that now only the end of the image is getting glitched. Okay. We could lower that quite a bit until we get close to the top, right? So now we're glitching a little bit more of the image. We can go even smaller than that and still not really mess with the header too much. So like 0.1, what does that look like? I've already glitched stuff up here. Let's go with that, okay? But so this is in percentages, okay? And it defines the start and end points to make mods within. Okay. All right. So we'll see. This might be a little bit too ambitious, but this means that the first 1% of the file is basically off limits, and everything else is fair game. Okay. I think I may have gone a little bit too far, so I'm still doing stuff. All right. So random bytes here is randomizing bytes. If you want this process to happen quicker, just by the way, you can put a bigger number here. Like we could say randomize 50 bytes every time. Okay. And now, of course, this is really going to quickly mess up our image as we change too many values at once. Okay. Yeah, even when we're not touching the header, like we start to get pretty, like a lot of junk. One of the things is that because the data is compressed inside a JPEG, there is kind of a logic to the way it's structured. So you can make small changes and see cool glitches, but if you make too many changes, you're just going to get mush and unreadable information. So something to keep in mind. Let's go back to like 2%, just maybe even 1%. That would seem fair game. Okay, so you can change random bytes like this. You can also say change a number of bytes at random and then replace them with a specific byte. For example, we could set them all to 255. So see what happens when we hit 255, or set them all to 1. Okay. Now this is a little bit different. So with this function, you can specify, change these bytes at random, but replace them with a specific value. Okay. All right. When things get too much out of hand, another thing we can do as well is we can say, let's say with a mouse pressed here, we can say glitch.reset bytes. So one of the things that the glitch library does is internally it keeps a clean copy of the bytes array so that you can reset. You can reset things back to the way they were when you started out. Doesn't seem to be. Let's see. Let's get it really messed up. And then if I press, you can see that it's kind of going back to a clean start. Now, of course, I'm constantly messing up the image here. So, but you can kind of go back to a known where you started up by doing reset bytes. Okay. Go back to begin. So this is one way that we can just randomly change things. Okay? Another fun thing to do is so this is a let's leave a comment here. Randomly change 5 bytes. Another fun thing to do is we can look for a specific byte. For example, we might go into data and say, let's replace all of the 48s. We're going to replace them all with 49s, okay, just for fun. So we're going to say glitch.replace bytes, and we're going to look for all the 48s. We're going to replace them with 49. So replace all 48s by 49s. Let's hit refresh. Okay, so that can be a really interesting way of glitching your image as well. So, and notice that doing the mouse press here doesn't really do too much because as soon as I reset bytes here, right, it kind of goes back and replaces all the bytes immediately in draw. And so this will, the nice thing with replace bytes is it will yield some predictable results. And you can kind of experiment with this and just to see what happens. For example, you know, you can just literally put whatever. So you can, a byte, it could be any number between 0 and 255. Okay? So you can write it, now here's another outcome. You can write it as decimal numbers like this. You could also write it as hex if you put it as a string. Okay, so you could write also hexadecimal numbers like this. So that's called replace specific bytes. So that can be fun to play with. You're basically replacing a specific byte with another number and then seeing what happens when you do that inside the image. So just to, so that's one way that we can, another way that we can play with it. And then the last way is you can use a function called replace hex. So replace hex allows you to search for a string of values. So for example, if we go back to the header here, right, a hex string might be FF, D8, FF, right, this particular pattern, right, or a particular sequence of hex values and then replaces those with a new sequence. Now this technique, it requires a really good understanding of the file format. And I myself, I'm not so good with JPEG files, the details of it. But one example that the glitch p5 library provides is replacing something called the quantization table inside the file. Okay? So somewhere inside the file there is this pattern over here, which starts with the code ffdb, and then it's followed by some numbers. Okay? And this is one of the tables in the header that will it's one of the tables inside the file that will drastically change how the data is interpreted when you decompress it. So one thing we could do is we could just slightly change this table for some pretty drastic changes. For example, instead of a 1 here, maybe we would put like a 2. Yeah. So see now the image is like looking really different. Or you could go more like dramatic. I'm going to put an F at the end. Now I'm really glitching the image. Okay, so this is this can be a fun technique to play with the caveat that it requires quite a bit of research into the underlying file format. Okay, so the with specific strings, in this case There's another one in the docs that's pretty fun to play with. And even those, you can experiment with the, just to see, replace X. So he's suggesting a couple here. So that's one of them. Here's another string that exists inside JPEGs that you can change the values as well. And I'm going to try it out, see what happens. So let's comment out this one, hit refresh. All right, so this one is changing more like the colors and the way the colors are being read. So it's kind of really creating some interesting results. All right. And just for fun here, let's also bring in another image. I'm going to copy this link. And just like we did in previous examples, we're going to be a bit lazy about switching between our different images. I will simply just comment out the first one. And when you use a black and white image, you can get some pretty different results. So for example, I'm not sure that one even has the color tables. That one, that doesn't even do anything on the black and white version. So different, that means there is information about the fact that this is black and white inside the JPEG header. This one, on the other hand, you can play with, and you create some like really fun glitches with this this first quantization table. So different files will yield completely different results. So and color versus black and white as well. Let's go back to our color image. Okay. So let's incorporate this. We're going to tie it up together. I don't want to spend too much time on glitching images. I mean, this is something you can kind of explore on your own, and really the whole point of it is to try stuff and see what happens. Oh, actually, one thing that can be good to know about as well is there is a way that you can save the images that you create. So let's search for the save bytes. Yeah, so it has a function called save bytes as part of the library. So if you've created an image that is interesting, you can say glitch.savebytes, and then we can give it a name. I'm going to call it test.jpg. Okay. And if I hit refresh here, in theory, if I press the mouse here, it would take the image and download it as a file. Except for some reason, which I could not figure out why, this doesn't work when we have the code side by side with the editor inside glitch. So if we want to see that this works, we're going to open this up in just its own window. Okay. And now if I press the mouse, interesting. Oh, save image. Sorry, not save bytes, save image. We're going to use save bytes in, let's try save bytes, save image. Yeah. Okay. So actually, I don't need to include the word JPEG at the end. And I clicked a few times too many. But you see, I downloaded some images here, and this is my my image. Now, it hasn't been glitched because I commented out all the glitching. Okay. But if, let's say, I put back this glitch, and then I wanted to save it as a file. Of course, you can also do a save frame through P5.js, but this is just nice to point out that you can do that with the library. So I'm going to hit refresh here, and I'm going to press the mouse. Sometimes you have to click it a few times. Oh, let's always allow downloads. And if I click now, it should download an image. It can be a little bit tricky to get it to work because of permissions. Okay, so there it is. And of course, I clicked way too many times. So here's my glitched image. So they can be downloaded that way. Okay, I got a little carried away. Here's the 7 times I clicked. Okay, let's go and get rid of these. All right. Okay, So let's tie this up by doing a little example where we're going to play with the replace bytes function. And we're going to create a little example where we're going to try to explore the space of replacing one byte for another. And we're going to do that using the mouse cursor. Okay? So for example, we could say instead of always replacing byte number 3, okay, we're going to create a variable. We're going to say map mouse x, which goes from 0 to width. We're going to map this to a number between 0 and 255, and we're going to use floor to make sure it's an integer. Okay. So here we're going to use replace as our variable instead of always being the variable 3. And then let's see what happens. Okay, so this might be too many bytes to replace. So the other thing we are going to do is we are going to reset the bytes so that we're not going to, because otherwise it would quickly fill the entire images with the byte A2. So we are going to start every frame by resetting the bytes from scratch. And then as I move my cursor, right, we're going to be selecting a different byte, right, from 0 to 255, and then replacing that byte with the value A2. Okay. And then we could do the same thing with the cursor up and down, right? Instead of finding which byte to replace, we're going to create a variable, let's call it by, and we're going to map mouse y, which is between 0 and height. Let's map it to a number between 0 and 255 again. And we're going to replace by that value. Okay. So this is going to allow us to play with our cursor and experiment. So to change, the x-axis is going to select which byte we're replacing in the file, and the y-axis is selecting which value we're replacing that byte with, okay, from 0 to 255 down here. And then we're going to have all the different kind of possible combinations in between of just glitching our image and just to see what happens. And that way we can kind of explore the space of possibilities. It's nice to do glitches like this through scripting and programming as opposed to messing around in a hex editor like that, because, you know, we could by trial and error try to replace every character with every other character and then save the file, open it, and see what happens. But inside P5, the cool thing is we can really quickly make some changes, and then you know, with reset bytes, we are effectively erasing those changes and then going back and trying something new. Okay? So there's kind of two different ways we can approach it. When we first started out, we just incrementally, you know, broke the file even more by just randomizing more and more bytes into it until it looked interesting. And then in this approach, we're taking more of a systematic approach, right? Trying to say, let's try all the different combinations of bytes that we could replace, right? From 0 to 55 to 0 to 255. And let's try them all out and search that space with our cursor to find some interesting glitches and just see what happens. And of course, we can combine these things as well, right? We could throw in this also in addition to that. We could mess the quantization table and, you know, just see what happens and then further, you know, further mess up the image. So this is pretty far from our astronaut that we started with. Yeah. Put a note here that this only works in a separate window. Okay. Okay, so this was a quick little intro to the glitch library and the byte replacing features that it has. In the next video, we're going to talk about opening another image type. And instead of images, switch to the black and white here. I just want to see what happens. So instead of the images, we're going to open a sound file, and then we're going to talk about how we would go and change the bytes in that sound file as well. And then save the resulting file so we can listen to the changes we've made. And we're also going to talk about how we can use this library to dig into the actual byte array that it creates. So not only does it allow us to do some glitching, it also facilitates opening kind of any kind of files and then having access to this convenient array of bytes, much like what we're seeing inside this hex editor. And then from that, we're going to convert those bytes to binary numbers, zeros and ones, and we're going to turn that into a visualization. So I'll see you in the next lesson.